So friends, today we will continue our chapter differentiation. Today we shall be discussing about the differentiation of standard functions. So the topic is the differentiation of standard function. So in the previous lecture we have seen that the first function we have seen where y equals f of x equals x raised to n. So in the previous lecture we have seen that its derivative or differentiation is given by dy by dx equals f dash of x, both are same thing. You can write dy by dx or f dash of x. So that is n x raised to n minus 1. This we have seen in the previous lecture. Okay, so now we will continue from there and we will see another function over here. Now let me just give you the brief introduction about the formula we are going to use. So the formula is called as first principle. The formula or basic tool we are going to use the first principle. The first principle, or it's a definition of differentiation. So we are using first principle or definition of differentiation. So you know that how we can. So it is like dy by dx or derivatives or simply f dash of x is given as limit delta x tends to 0 f of x plus delta x minus f of x divided by delta x. This is basically what we call as the first principle. This is the first principle. So we are going to use the same again. So today we shall take the next example, that is that is second example. We can take second function. So it is called as constant function which is a constant function. So for constant function the example is very simple. We can say y equals f of x equals some constant c, where c is a constant, or it is independent of x, we can simply say. So if f of x is c, then f of x plus delta x, because it is a constant function, the value would remain same. It will not change at all. Okay, this is basically, we can write down like this. So by first principle or by definition, derivative is given by dy over dx given as limit delta x tends to 0 f of, I am simply using the same formula, same result, which is this one. The same thing I am following. So x plus delta x minus f of x whole divided by delta x. And if you write this, it is again very simple. F of x plus delta x is c minus c over delta x So the value will turn out to be, so we can say that differentiation of a constant function is 0. Okay, that means if I write dy dx of constant c, that is 0. If I write dy dx of some constant m, that is also 0. Okay, so constant in the sense it does not depend on x. X is a variable, so the function which does not depend on x is a constant here. So anything you can write down, a, b, c, anything which is constant, its derivative is going to be 0. So this was the second function. We can also have third example where you can take trigonometric function. There are so many trigonometric functions. So anyone you can take. So for example, we can take trigonometric function as y equals f of x, as we can take sine of x. We can also take cosine of x. The same procedure can be followed. So if I take y equal to f of x equal to sine of x, then what is going to be f of x plus delta x? So I will change the value of x to x plus delta x. So that is going to be sine x plus delta x. Okay, so by definition again, by definition or by first principle, same as f dash of x, first derivative, dy by dx, or derivative of y with respect to x, that is f dash of x. Same formula I am going to use, same result, that is limit delta x tends to 0, f of x plus delta x minus f of x divided by delta x, which can be simplified by substituting the values of f of x and f of x plus delta x. So that will be simple, limit delta x tends to 0. So f of x plus delta x is nothing but f of x plus delta x is nothing but, this value is nothing but sine x plus delta x, right? So I can put that value, corresponding value here. So it is sine similarly f of x is, you know that it is sine of x whole divided by delta x. Now there is a rule, there is a simple rule of sin A minus sin B. So we can follow that rule here itself. So let us use that result, trigonometric result, that is sin A, we have sin A minus sin B. Sin A minus sin B. So what is sin A minus sin B? It is 2 cos A plus B by 2 into sin A minus B by 2. 2 cos a plus b by 2 into sine a minus b by 2. This is the result we have, right? So if you use apply same result in the given situation, therefore if you apply the same result, so you shall get dy by dx limit delta x tends to 0. Now sine a, so this is nothing but a, we can use this as a and this is b, sine a minus sine b, so it will be 2 times cos, now a is x plus delta x plus b is x divided by 2 into sine x plus delta x minus x, that's okay, whole divided by 2, and then we have here in the delta x in the denominator. So if you simplify this, 2 can be taken outside, so you shall be getting limit delta x tends to 0 cos of 2x plus delta x by 2. This part is very clear. So we have applied limit to the first part. We can also apply limit to the second part. So what you will be getting, limit delta x tends to 0. Now you will see here this x and this x gets cancelled out, so you will be getting delta x by 2 remaining. So it is sine delta x by 2 whole divided by delta x, which was in the denominator actually. So what I can do is, I can take this 2 outside and I can bring this 2 from outside, and then that I can bring it here in the denominator, so that you will get a proper form. I will tell you what form we are looking for. So you shall be getting limit delta x tends to 0 cos of 2x plus delta x whole divided by 2. Absolutely no problem here, and here you shall be having limit delta x tends to 0 sine delta x by 2 divided by delta x by 2. Now let me explain you why we have made in this form. This particular form is important actually. This particular form is important to calculate limit of function. So this is because we have a standard result for limit. So what is the standard result of limits? If we have limits theta tends to 0 sine theta over theta, this value is 1. So whatever angle you have in the numerator, the same angle should be here, and the same should be here in the proportional in the limits. So these results we can use to get what you call the proper solution for our limits. This is there, since this format is there, so we will now do it in the same way. Since this also we can write down here delta x by 2, because as delta x tends to 0, delta x by 2 tends to also 0. Okay, that value will not affect much. So now I will take the limit. So taking limit here, if I take limit, so I'll end up getting dy by dx equals cos of, now delta x is 0, so this value will get cancelled out, so 2x by 2, so it is only x, so cos of x times, you will get here, this value will be equal to 1, that format if you see, so that is equal to 1. So hence you will get dy by dx or f dash of x equals to cos x. So derivatives of, we got derivatives of sin x as cos x. Derivative of sin x is very simple, it is cos x. So derivative of sin x is cos x. Okay. So similarly, we can also write down other trigonometric functions. So this was the first function we discussed actually. This was the first function. We can also take this was actually a, I must say, but we can also take for trigonometric function cos x, tan x and sec x, and individually we can derive for each of them. It is quite possible. So let me take another one, cos x here. So I will be taking cos x. So b is cos x, f of x equal to cos x. So I am keeping it here for your understanding. You can refer them whenever it is required. So let's start with the next one, f of x equal to cos x. So obviously y equal to f of x, I can write down x plus delta x, f of x plus delta x equal to cos of x plus delta x. So by first principle, by first principle you may get something interesting. So what is it? Therefore by first principle derivative dy over dx, that is equal to f dash of x, that is, you already know the formula, limit delta x tends to 0, f of x plus delta x minus f of x whole divided by delta x. So you can substitute the corresponding values. So what are the values? So it is x plus delta x is, f of x plus delta x is cos x plus delta x, x plus delta x minus cos x whole divided by delta x. So now if you look at this, you will see I can use for this I can use cos A minus cos B or cos alpha minus cos B, this particular rule. I can use this particular result to find out what you call, so this will become alpha and this will become beta, for instance. Okay, you can use this as alpha, this is beta, and we can apply the same formula here, this one here, and you can simplify it. So let us see what simplification we get. So we shall be getting limit delta x tends to 0. Now here we have minus 2 times sine of alpha plus beta by 2. So alpha is x plus delta, and then x plus delta x plus x whole divided by 2 into, again you will get sine. Now alpha minus beta by 2, so you will get x plus delta x minus x whole divided by 2. And then we have in the denominator delta x. That will be as it is. So now things will be simple. Again, no need to bother much because I will take minus outside now. So sine x plus delta x by 2 will turn out to be 2x plus delta x by 2. That's not a big deal for us. This value can be easily, if you substitute value of delta x, if you substitute the value of delta x as 0, the value will be simplified. There is no big deal problem at all. Now here we will do a similar method as we did in the previous problem. Limit delta x tends to 0, xx gets cancelled out. Okay, so delta x by 2, so I can write down this as delta x by 2 directly, and then sine delta x by 2. The quantity 2 was outside here in the previous case. This 2 I will take in the denominator, so this will become delta x by 2. So this whole thing will turn out to be 1 as far as the standard result is concerned. What is standard result? Since limit theta tends to 0, sine theta over theta equals 1. So we can use this standard result. So this whole value would give you 1. So what is your derivative now? So dy by dx or f dash of x would be simply, this will be cancelled out, so we will get minus sine x. So derivative of cos x is minus sine x. So this is the result of derivative of cos of x. We can similarly proceed and we can find out, similarly we can do number of things. So we can also take, if you take similarly, please all of you try to solve it by yourselves. Try to find the standard result for other functions like y equals f of x equal to secant or sec of x. Its derivative you will get, if you follow similar method, you will be getting sec of x into tan of x. If you can't do it, just put in comment. I will again derive them and show you again. Any difficulty is there, we can discuss. Similarly, if you have y equal to f of x equal to cosec x, you will be getting dy by dx, that is f dash of x equals to minus cosec of x into cot of x. Sec and cosec. We can also take similarly derivatives of tan of x. If you do, you will end up getting secant or sec square of x, and derivatives of, if you do cot of x, you will be getting minus cosec square of x. Okay, so these are some trigonometric functions: sine, cos, sec, and then we also correlated for tan and cot. So these are, we have done few of them, like we have taken trigonometric functions, and we discuss how to deal with trigonometric function. Okay, now there are few more functions which we need to do. So the next type of function are we can say exponential functions. So in the exponential function, basically we shall be getting some constant raised to variable. For example, it is in the form of y equal to f of x equal to some constant, let us say a raised to variable x. This is the example. This constant a can be anything. Here a is a constant. This a is a constant, friends. So here a is a constant, arbitrary constant we call, but simply we should say it's a constant term, and x is a variable. That's, you already know, we are using x for variable. So how to deal with such kind of function? So try to solve them following same technique. So here, if y equal to f of x equal to a raised to x, therefore f of x plus delta x would be a raised to x plus delta x. We will simply substitute x by x plus delta x. Okay, or by first principle, we are following first principle kind of thing. By first principle, what we can get? We can write that derivatives dy over dx or f dash of x, the derivative of function, is same results or same notation. We can write delta x tends to 0, f of x plus delta x minus f of x whole divided by delta x. So let's substitute the corresponding values. So limit delta x tends to 0. So now this is a raised to x, can also be written as by using indices rule, a raised to x times a raised to delta x. Both are same thing. Okay, so I would prefer writing this a raised to x. This one I would write. Okay, so it is a raised to x times a raised to delta x. So it will be easy for us to deal with it. Okay, minus what is f of x? That is a raised to x. Okay, friends, whole divided by delta x. So now let me write down limit. So now here our the variable for limit is delta x, not x. So x you can take out of the limit, because the limit is only valid for delta x. Wherever delta x comes, there you have to put 0. Okay, so let's see. In this particular thing, if you see, a raised to x is common in the both terms, if you look at. So if you look at here, now this a raised to x is here also, and a raised to x is here also. So I can take these two terms common, and then inside you will have a raised to delta x minus 1 whole divided by delta x. Now mind it, friends, we have a standard limit rule where limit t tends to 0, a raised to t minus 1 upon t is, this is called as a log of a. Log of natural log, it is basically log to the base e, a always. you might have remember similar formula like limit x tends to 0 a raised to x minus 1 over x, that is log a. So whatever constant we are using here, the same has to come. If it is a, the a has to come here. If it is b, b has to come there. So this is actually important result for calculation of trigonometric exponential limits. So by this rule, if you go, you can, this is very similar to that. So what I will do is, now I will modify it. It's almost done. I will take a raised to x outside because limit is not applicable for this. Limit is only applicable for delta x. So I'll write down like this: limit delta x tends to 0, a raised to delta x minus 1 over delta x, and that whole value will turn out to be, therefore dy by dx or f dash of x will be a raised to x times, this is going to be, if you look at here, this is going to be log of base e, actually log of a. So it is going to be log of a, natural log of a. Okay, so we could easily find out the derivatives of a raised to x. Here a can have anything, a can take any constant value. Okay, any finite constant value is applicable for value of a. This is very important result. So similarly, I can extend this concept. I can extend this concept to e raised to x also. Similarly, if y or f of x equals e raised to x, so now a is replaced by e raised to x, then its derivative dy by dx or f dash of x can be similarly written as, what is that? A raised to x means e raised to x log of e. Instead of a we got e, right? So it will be log of e, right? Similar to that, because here we had a, here we had a, you can see here we had a, so instead of log a we shall be having log e, similar to it. Okay. So now that, but log e, natural log of e is 1, therefore e raised to x. So simply we can say derivatives of a function like e raised to x is straight away e raised to x.